So far in these videos, we've seen aldol reactions where there is one carbonyl containing starting material. But it's possible to do an aldol reaction between two different carbonyl containing molecules. So here's an example. If we have something like benzaldehyde and propanol. Here's benzaldehyde. And propanol. This can undergo an aldol reaction. We have sodium hydroxide, so we have a base in water, and we will add heat. If we look at benzaldehyde, it has one alpha carbon, but there are no alpha hydrogens there. So we cannot form an enol or an enolate with benzaldehyde. The only starting material that has an alpha hydrogen is propanol. So if we're doing an aldol reaction, only propanol in this example, so not benzaldehyde, can become an enolate ion. So once propanol becomes an enolate ion, that enolate negatively charged carbon could add to the carbonyl carbon in benzaldehyde. So let's draw what that looks like in a mechanism. So first step of aldol reactions is forming the enolate, and that can only occur in propanol. So that will be in our first step. I'll draw both alpha hydrogens coming off of the alpha carbon. We have hydroxide as the base. So electrons from oxygen will take a hydrogen and we form that enolate ion. So here is our enolate, showing the form with a carb anion, so negatively charged carbon. This is the form that will show in mechanisms. Now we have our carb anion. This is a nucleophile, has electrons to give away. If this is in the presence of benzaldehyde, well, we have our electrophilic carbon in benzaldehyde in that carbonyl. So this nucleophilic carbon can create a bond to the electrophilic carbon, and we break that pi bond. So now we've taken two different carbonyl containing molecules and created a new carbon-to-carbon bond between them. I'm going to rearrange this a little bit and draw the phenyl ring on the left of the molecule. So this phenyl ring is bonded to a carbon that now has a negatively charged oxygen. So that's this one here. The hydrogen is still bonded to that carbon. I'm going to kind of draw it off to the side though. We have a new carbon-to-carbon bond. I'll emphasize that in green. So we have a new bond to a carbon atom, and that new bond is to this carbon. So that carbon is now bonded to a methyl group and the carbonyl. And a hydrogen, we'll put that off to the side. All right, so at this point we have accounted for all of the atoms in the enolate and in the benzaldehyde. So we have a negatively charged oxygen, we have water present, we'll neutralize by protonating the oxygen. And with this step, we form the aldol product. In this case, it's an intermediate. I'm going to only emphasize the aldehyde hydrogen now. So this is where the reaction would end, remember, if there is no heat. But with the heat, the reaction continues on. And the next step is, again, we're working with base, and this base will remove an alpha hydrogen, and it removes the hydrogen at the alpha carbon that had previously lost a hydrogen. So that's this one here. This is the alpha carbon to the carbonyl carbon. This is the alpha hydrogen. So the hydroxide takes the hydrogen, and we again form a carb anion. So we have a lone pair and a negative charge on that alpha carbon. Our last step is forming the enol product. So the pair of electrons creates a carbon-to-carbon pi bond, and the OH group leaves the molecule. So our final product is the enol product. New carbon-to-carbon pi bond, and everything else is still present except for the OH group, which we have lost. So this is the final product. Again, it's an enol, carbon-to-carbon double bond, and an aldehyde. Now, I've mentioned in previous videos that forming conjugation or producing conjugation in the final product promotes the forward reaction to produce the enol. In this case, when you're using benzaldehyde, that conjugation is extended even further. So we have extended conjugation. And this promotes the forward reaction. Let's think about which atoms are conjugated here. Well, we know we have conjugation throughout a benzene ring, throughout the phenyl ring. Those pi bonds can resonate. If we look out of the ring, we have a single bond, double bond, single bond, double bond. So the pi electrons that are currently highlighted in blue are all conjugated with each other. They can resonate across those atoms there. So our mechanism is the same as the Aldol condensation reaction. We are just using two different carbonyl containing compounds as the starting material.